Okay, I think everybody should be here now and we can start with the webinar. I welcome you to this webinar about the ABCs of graph styling. My name is Benjamin Niedermann. I'm a software developer at WiWorks and I'm happy to welcome you to this fourth episode of the series, The Art of Graph Visualization. In this series, I show you how to create not only beautiful, but also meaningful and useful graph visualizations. And with meaningful and useful graph visualizations, I mean visualizations that you can use to gain new information from your connected data. So in the very first episode of the series, I gave a very broad overview of the most important aspects that you need to take into account when creating a graph visualization. So these aspects were, of course, the problem setting. So what kind of question would you like to answer with your graph visualization? But it was also about the analysis of the data and the layout. So the decision which kind of layout you would like to use to visualize your data. But there are also the aspects about styling and interaction. And in the first episode, or in the second episode, I showed or argued that it's really important to have a preparation phase where you first analyze your problem setting in detail to really understand the question that you would like to answer. And then in the third episode, I showed how to create the layout, so choosing the right layout algorithm. And today I would like to go to the styling. So about the question how to color, for example, the nodes, how to choose the shapes of the nodes, the shapes of the edges, and so on. So it will not be about making the graph beautiful, but it's more about enriching the graph with further information so that you can actually gain new information from this graph visualization. So in this webinar, I show you how you can use styling as a tool to annotate your graph visualization with further information and also to highlight key information in your visualizations. And the webinar will be structured as follows. I will discuss four main aspects, namely visualization, visual encoding principles, and also technologies that you can use. Here I only will give a few examples. So in the first part, I will talk about what elements can we actually style. So for which elements can we choose colors and shapes and so on. And of course, this comprises mostly the graph because we are interested in graph visualizations, but it also comprises the background of the graph visualization as well as the decoration. After that, I will talk about visual encoding. So which visual elements can we use to encode further information and what type of information can we actually encode using these visual elements. In the third part, I then will talk about the principles that you should take into account when using these visual elements, because it's really easy to accelerate on these styling tools, and then you get a visualization that is just cluttered. So it's really important to know the basic principles to get a graph visualization that is easily comprehensible. And then finally, I will also talk about technologies. This is a really broad field, and I only will give 4 examples for this, which are also supported by WiFiles, so the main product of WiWorks, so the SDK that you can use to create graph visualizations. And in this part, I will also show you some examples how this is done in WiFiles. So let's start with the webinar or the main part of the webinar. And I don't want to do this on a theoretical level, but I want to show you a lot of examples. And I also would like to use one main example that I already have used in the other episodes of this series. And this example I would like to first introduce before we talk about these 4 aspects. This example is based on a music database called Discogs, and this music database is a Wikipedia-like database. So thousands of users have maintained this database over years, collecting entries for example, artists, music releases, and also music groups. And in this series, I use this as an example how to create a graph visualization from scratch. And I would like to now sketch the idea of this graph visualization that we would like to create based on the database. So the idea was that we would like to visualize the history of artists. And the basic idea is that each artist is represented in our graph visualization as a path, starting with a node representing the artist, here, for example, Paul McCartney, and then in the order of the music groups, how they have been founded, the path traverses the music groups the artist was member of or is member of. So Paul McCartney is member of the Beatles, then also of Linda and Paul McCartney, and also of Wings. And doing this for many of the artists, we get an entire graph visualization showing us the history of the artists. So in the last episode, I already showed you how to create a layout based on this database. And today I would like to talk about the styling. So that you get an idea how this visualization looks like, I would like to switch to our playground. And this playground you can also find on our homepage. But we also will post the links in the chat, or if you watch this video after the webinar took place, so if you watch it on YouTube, you will find the link also below the YouTube videos. So I just run this code here. So the playground is a typical playground where you can just try out some source code. Here in this case, Y-files. So here you can use the Y-files library to just play around with this. And I also done this and have used a snapshot of the database, or basically a reduced snapshot of the database. And then I've created, or I wrote some code that creates the graph visualization on the right-hand side. So if you are just at the very beginning of using Y-files, this is also a good place to start, where you can just use the playground. Here you can also find some examples starting with this. And in this webinar, I will typically use this playground here. So back to the visualization. Here you can already see how the visualization looks like, and it's already styled, and it also has some animations. As I said, the artists are represented as single nodes. Each here is represented as a red node, and then there are paths going through these music group nodes. So for example, here the Quarrymen, and then also the Beatles, and so on. And this gives us an information about the artist and the history of the artists. Apart from that, I've also added further information in form of these genre nodes. And so what I've basically done is that these music group nodes are actually group nodes in our graph visualization, each containing further nodes representing the genres in which the music group has published songs. And depending on the number of songs in the genres, the sizes of the nodes have been chosen. Apart from that, what you can also see is that each path has an edge label, which tells us to which artist, to whom this path belongs to. So this helps us when traversing here this path. Apart from that, if you are interested in just highlighting some of the artists, we also have the possibility to use animations. So this is how the visualization works, basically. There's some further background image, namely this table here with these with the decades, and the music groups are sorted into these decades. So this is basically the visualization we are looking at during the webinar. If you want to just try out this visualization and play around with this a little bit, then you can also go to the playground. You find the very same example, and then you can start working on this. So in this webinar, I won't go too much into details about the coding. There will be an extra webinar where I explain how to create the styling for this graph visualization. However, if you're interested, you can have a look at this method here, or this method call here, which basically creates the styling. And here you can also play around a little bit with the highlighting. So for example, you could enter some other name, let's say Yoko Ono. And we recalculate this, and now the path of Yoko Ono is also animated, and we can easily follow it. So this example I will just use as an example how to style a graph visualization in the main part. So let's go back to the presentation. And now I would like to talk about the main aspects when styling a graph visualization. And I would like to start with the visualization itself. So we should clarify some terminology so that we can be sure what would we like to style. And with styling, I always mean choosing colors, setting the shapes, and so on. And the first observation is that the graph visualization that we are given is a layered visualization. So basically it consists of several layers. So the background layer, then the graph layer, and then the decoration layer. The graph layer itself may also consist of multiple layers, depending on how you arrange or how you define the set orders of the elements. And in this webinar, I mainly will consider the graph layer. And the graph layer consists of the typical elements. So there's the node, of course, and the edge, but we also have a group node. And then we have some external node label that is placed here for this group node, but we also have internal node labels, and we also have these edge labels, which are really small. So these should be only some hints for people following the path. These are the main elements of the graph layer, and the question is, how can we style them? And to that end, we should know about the visual elements that you can use to style these graph elements. So of course, what you can do is that you can use the color, and the question is, what can you express with the color? And one obvious thing is that you can express types and categories. So for example, in the graph visualization about the artists, I've used red colors for the artists and blue colors for the genre nodes and the music groups. So there's a really clear distinction that the two different colors belong to different graph elements. But of course, you can also use other techniques, or you can also use highlighting or colors for highlighting. Here, I don't want to show this in the artist example, but in another example, which I just start here. This is the Liga graph. I just need to jump over this introduction. So this is basically a graph showing the matches of basketball teams and how they ended. So it basically shows the results. And what you can do is, of course, you can color the entire graph, but you can also use colors, for example, to highlight edges, single edges, or maybe the entire neighborhood if I hover over some single node. These are typical applications for highlighting and using colors in highlighting. What you also can do is you can use colors for the background, basically, so that you place the color or the highlighting color in the background, so that you don't change the graph elements themselves. Here, this is a network that shows basically packages that are sent, or it's a process diagram, and it shows some process sent through this network. And what you can see is where the bottleneck is of this network. And it's really easy because it's just highlighted by these red areas. Later on, we will also see an animated case of this. There it's even more obvious where the bottleneck is. So colors for highlighting, but what you can also do is using colors for hierarchical levels. So here in this case, I used colors for different types of nodes. So these four groups here and then this inner node, but I also used the brightness of the color in order to express the hierarchical level. So here we have very bright colors for the leaf nodes and less bright colors for the inner nodes. And this gives us already some hierarchical level and also tells the viewer where to look at. So in this case, typically we tend to look more at the bright colors, so we tend to go to the leaf nodes of this graph visualization. By the way, this is actually in graph visualization. So this is the so-called cactus layout. So the idea is that you don't express these edges by normal edge routes, but by contact representation. So that you say, okay, this node here is connected with this node just because it is connected. It's very intuitive. I also have used this layout on the left-hand side, but here I have used a different coloring strategy for the hierarchic levels. So what I've done here is I used the bright color for the center node and the less bright colors for the leaf nodes. And what happens now is that you tend to look more at the center of the graph visualization. You can also, of course, use colors to express clusters and to show some kind of grouping between nodes without putting the nodes actually into groups. This is also an example that I would like to show you. Here it's about a recommendation graph for board games. Actually, we have placed here the graph on several layers, and the colors here have been used to basically visualize some clusters in this recommendation graph. And of course, what you then also can do is not only use these colors or for the graph elements, but also for the background, which gives you a nice impression which of the nodes actually belong to each other here on this layer. But on this layer, you also can easily comprehend this because the nodes have the same color. So these are typical techniques how to use colors in graph visualizations. Probably most of them will also you already know about this, but sometimes it's also good just to see many examples about this to get some idea and intuition how to use such visual elements like colors. So the next thing that you can, of course, vary is shapes. So what you can do is, again, you can express types and categories. A very typical examples are these BPMN diagrams or UML diagrams, where each shape has a very predefined role in your diagram. So basically, there are official specifications that tell you how the shape of the node should look like. So typically these fork nodes are diamonds, and then we have these processes which are these rectangular nodes, and then we also have some other nodes which are round nodes. And these shapes are predefined, and the idea is that anybody who knows the specification can easily read this graph visualization because you can just rely on this, that what kind of information is conveyed to you by this shape. By the way, if you want to try out these demos on your own, most of them are interactive. You can easily do this on our homepage. Just go there to the demos, and there you get a really large set of demos that you can try out. So the next shape is typically, in our example, of course, I also would like to mention this, is that for the artists nodes, we have just used rectangular nodes. Here, the idea is that we just want to place a label, and these nodes should not be too large. So we should use a shape that basically suits a label very well, and this is basically a rectangular node. More interestingly, for the genre nodes, we have used circular nodes or circles, and the idea is that these kind of shapes can be easily compared to each other. So it's really easy to say, okay, this node or this area of this node is larger than the area of this node. Also, the difference is only small. So here we are really good in distinguishing the sizes and assessing the area. So if you want to express such information, often it's suitable to use circles. Another shape, a very obvious shape, which everybody knows, are directions, so arrows basically, to show in which direction at an edge points, but you can also, of course, use this for nodes and so on. So here it's a very clear interpretation how to read these graph elements. And then another way to use shapes is to change the shape of the edges. So just by saying, okay, I would like to use orthogonal edges or curved edges. In this example, you see in an org chart of a company, so a hierarchical structure of the employees of the company, and the structure is a tree structure showing the hierarchies and teams. So these gray edges here. But also what we've done is we added further edges to this hierarchy, expressing which or who of the employees have collaborated to each other. And here the idea is that orthogonal edges just say, okay, we use them for the hierarchical information, and for the other information level, so for the collaboration level, we use curved edges. And of course, we can do this in a combination with colors. So we also used different colors for this. This is also a typical thing that you find often in graph visualizations, that you combine visual elements with each other and to express your information. So sizes in graph visualizations are also very important to express attributes. And in this example of the history of artists, we have used this both for edges and nodes. So for nodes, we have just said, okay, the genre nodes should correspond, or the size of the genre nodes should correspond to the number of releases the music group has in this genre. So for example, here are many releases in pop, but only few releases in blues. And with this, what also happens is that this entire group node also becomes larger. What you also can do is to express attributes via edges. So for example, here what we did is that artists with many releases have a fat edge, and artists with only few releases have a very thin edge. So if you take a look at the entire graph visualization, then you can easily identify artists with many releases, so with a high impact to the community, and artists that only have few releases. And this, of course, also helps you to express importance and centrality in your graph visualization. So sometimes these music group nodes are small because the genre nodes are small. Then it's obvious that this music group has only a small influence. While a large node means, okay, it probably has a high influence, so it's of a high importance. And this is also a typical way. So if you assume that you take a high-level overview of this entire visualization, then you can easily spot these music groups that have a high importance in the graph visualization. And finally, or not finally, these are only 3 examples. There are probably many, many more, but one possibility is also to express hierarchical levels, also again together with colors, for example. Here I also would like to show you a short demo. Again, using a graph, and here the idea is that this is the root node, so the center node of the entire hierarchy. And what you can do is you can unfold these nodes further and further, and now the sizes become smaller and smaller. So this basically means that a small node is placed in a lower level of the hierarchy, and this can be also easily comprehended. So this is the balloon layout, by the way. You can also choose another layout, namely the cactus layout. This is the very same graph. and then you can see how this node is expanded further and further. Here, the size not only corresponds to the hierarchical level, but also to the number of nodes that are adjacent to this node. So sizes are also very manifold, how you can use them to express your information in the graph visualization. And then finally, for the visual elements, I would also like to mention animations. This is also, of course, an important way to express information if you have a digital visualization. Animations, of course, don't work for print, but often we would like to use visualizations, for example, in web. So here animations make really sense. And what you can do is you can express flow and movement. You have already seen one example. Namely the artists of history, the history of artists. So if we go back, you see here this very nice animation that just goes from John Lennon and helps us to follow this path. I also added some other in highlighting. So for example, I just said, okay, it would be nice to highlight one genre, namely the rock genre. And now we can, if we take the overview of the entire visualization, we can easily spot the nodes or the rock nodes and how large they are. By the way, integrating these kind of animations is not very difficult using WAV files. You can just configure a CSS style that is then basically attached or anchored at these elements. And here you basically use typical CSS techniques where you just define very shortly how you would like to animate the path and then also how the animation looks like. So this is basically not a thing that is done by WAV files, but basically by the web technology behind that. So in that case, using SVG graphics and CSS as styling technique. So this is one possibility. Another possibility, I've already said this later before, is this animation here, where you not only have a path that is animated, but what you can do is you animate objects going through this over these paths, telling you how heavy the load of the path is, and what you can actually see is then very easily how the or where the bottlenecks are. So if I restart this animation, you can see how the nodes go through the different paths. And then at some points we have these red highlights showing you basically the bottlenecks or the heavy load of this network. Of course, you can also use highlighting just for animations, just for highlighting techniques. So in order to, for example, react on interactions with the user, here I would like to go to a very simple demo that you can also find on our homepage, where it's just, it shows you how to animate, for example, certain graph elements. Like if you hover over this, then it starts pulsating, and you can use different types of animations, and you can play around with this and find out on your own how these animations could work. But basically, these are typical animations that you can use to react on user interactions, or also to just visualize events where just to say, okay, at this node there was some event, and I would like the user to focus on this event. Let's see whether I can find. This is, for example, the beacon animation. This would be a typical animation for events that have occurred, and you would like to get the focus of the user to watch at this particular node, or in this case, about at these multiple nodes here. And this brings me also to another point which is really basically, which is really similar, and it's also basically about highlighting its events. So here the idea is that you use highlighting and animation techniques to visualize the events. You can also have a look at this example here for network monitoring. And you can, here again, we have some packages that are sent through this computer network. And now what we can do is we can simulate failures. And now it's, of course, a bit difficult to find out where the failure is, but the animation will show us. I hope that it will appear in a few seconds, so I cannot control this when the failure appears. But typically, it's, now here the failure is, we get it zooms in, and now it's also animated, which really brings our focus to this device here, or in this case, to this device, and so on. So animations are also so important to get the attention of the user. So if you already have a lot of information in your graph visualization, animations can help to bring the focus to certain elements of your graph visualizations. Or also to show or give some responses on user interactions. So in the next webinar, this will be about interactions. There I will also talk more about animations and interactions. So these four basic visual elements, of course, are not all, but already important elements that you can use. But the problem is if you overdo this, or if you exaggerate on this, then your graph visualization becomes easily cluttered. So it's really important to know some basic principles, and most of these principles I think are obvious, and you would say, okay, I already thought about this, but maybe there are some ideas that that could help you to improve your own visualization. So the design principles, so this is also a really broad field, and I would like to mention some of the examples, of course, important examples. One principle is consistency. So here the idea is that the user gets an experience that is predictable and coherent for the user, so that the user can actually predict the behavior of your graph visualization. So what I've done, I've used, for example, in here the same colors for the same type of node. So the user can actually predict, okay, blue nodes, if I see a blue node, this will be a genre node. A red node will be an artist node. So here consistency is really important. And consistency basically, or in order to gain consistency in a systematic way, what you can do is you can define rules and schemes for your for different aspects of your graph visualization. So for example, for the layout, for the color, for the typography, and also for the symbolism, and many more. And this is, of course, a bit time consuming, but typically it pays off, and often you can reuse these schemes also for other graph visualizations. So here in this case, for the layout, of course, you can take a broader view on the layout and also think about layouting the nodes, and so placing the nodes and routing the edges, but it's also about how to place labels, for example. And here I said, okay, in order to have this coherent experience, I always will place labels of the artist as internal labels, and the labels of the music groups are always external labels. Then we also have flow aligned edge labels. So I don't mix this. So what I could have done is that I could have placed some of the labels internally and some of them externally for the music group, but this wouldn't be consistent anymore. The same for the color. I used red color for the artists and blue color for the edges and for the group nodes. So there's a clear difference between artists and the rest of the graph visualization. For the typography, I only used same font sizes and colors for the same type of graph elements. So I used large fonts for the music groups, very small font sizes for the edges, and here the same font sizes for the artist nodes. Here the idea using this again, it's also about importance. Using large labels, for example, expresses importance. So saying, okay, these edge labels are really small, it's more like, okay, this is an additional information that the viewer could read, but it's not necessary. And for the symbols, for the symbolism, I really used a simple approach where I've just said, okay, same shape for the top level nodes and circles for the shortest nodes, as argued before, in order to express the sizes. Here you can typically become also more complex. So for example, in these business process model diagrams, there you can typically use many more shapes as they have predefined roles. But again, think about or try to minimize the number of different shapes, for example, that are used. And this basically brings me already to the next principle, namely simplicity. And this is often, so everyone would say probably, yeah, it's obvious to use simplicity, but it's often very difficult because you want to express a lot of information with your graph visualization, but then you need to reduce this somehow and map this on a very simple set of visual elements. So here it's really about reducing unnecessary complexity. Sometimes complexity is necessary, but if it's unnecessary, then leave it out. So in this case, we just used 3 different label positions. We used only a small set of colors. So at the beginning, when I've created this graph visualization, I thought about coloring each genre with different colors, but then it became really colorful and was really difficult to basically read the graph visualization because this was a bit overwhelming already. So I decided, okay, only 2 colors, namely blue and red, and then I allow some shades. The same basically I also did for this entire presentation here. I only used few colors to express the information. With typography, I only varied the size, and also for the symbolism, for the shapes, for example, I used only 2 different types. So yeah, here it's really pays off to invest some time to think about how to gain or to achieve the simplicity because this typically improves your visualization quite a lot. The next principle is visual hierarchy. This is basically what I also have basically mentioned at some of the points before. It's about importance. Visual hierarchy should guide the viewer through the information. So it should help the viewer, so the user of the graph visualization, to read the graph visualization. So small things should be less important so that basically the user knows, okay, it's not that bad if I don't read them, but really important information should be on a top level of this visual hierarchy. So in this example, I used the size of elements in order to represent importance, but I also used muted colors for the background and bright colors for the graph elements. And this is a typical way to do this. So if you remember this table in the background of the visualization, this was really basically already black. It's only had it was a really dark gray that I've used because I said, okay, this is not that important for the use of the graph visualization. And finally, I would also mention mention the Gestalt principles. Here, the idea is these are a set of psychological principles that describe how people perceive and organize visual information. And this is also has there are different definitions, or there are different principles within these or Gestalt principles, and I would like to mention the most important for graph visualizations. So this is good form, proximity, similarity, continuation, and closure. So what do I mean? So when a user looks at your graph visualization, then typically some visual effects will appear so that he or she will perceive the visualization in a certain way. So for example, a user typically tends to group objects. So if we group these or place these objects very close to each other and they form a square, then you typically see the square. It's not that you see the single object only, but you basically see the entire object. Proximity means that you typically group objects, visual objects, by their distance. So it's really clear that this is a group and this is a group, only because we have here this gap, which is larger than the other gaps. Similarity means that using similar shapes also tends or let the user think that this is a group. So here it's clear that this is a group, this vertical or this column here, and this is basically a group of objects. So only by placing these objects, we haven't given any information about this, but just by visual experience, we would say, okay, these form these different groups. Then we also have continuation. Here we have basically these elements, these visual objects here, this segment and these two segments, but actually we would perceive this as one segment crossing another segment. And then finally, the closure means that we often also use the complement to see shapes. So in this case, we typically see here this black shape and not the red shapes, because this black shape is more familiar also for us. So what does this mean in graph visualization? So proximity, I don't want to go through all, but some of them. So proximity basically means that we need to take really care about where to place our labels. For example, here we have this label, the Beatles, and because it's placed so closely to this group, it's very clear for us that this label belongs to this group. The very same you can also find here on the left-hand side. For us, it's just clear that these labels belong to these small nodes because just by the placement. And such kind of examples you always or you can find in graph visualizations. Also put differently, if you place an object too close to another object, also they do not belong to each other, the user may perceive this as a connection. And this could be wrong, this connection. So you also need to think about introducing actually gaps between objects. Here similarity is also just by similarity, we can easily say, okay, which of these nodes belong to each other or which of these nodes have certainly the same type. So if I go to this example here, this is a Game of Thrones graph. Just by the shapes of the nodes, we basically can say, okay, this represents the families, and then here we all have the same shape, so probably they represent the members of the families and so on. So just by similarity. So next, continuation is also an important thing to know in graph visualizations. Often we have the problem that when routing edges, we get some crossings, and actually introducing crossings is not always that bad. Sometimes it's really okay if you don't do this too much, because we are able to continue this edge routing along this crossing. So it's really clear that this edge here goes from node 1 to 6 and not from node 1 to 7 by going here and making here this band. So this is basically obvious for us, but this is the reason why we can also introduce crossings without the fear that that people will misunderstand the graph visualization. But of course, don't introduce too many crossings, otherwise it will be too complicated, too complex to follow these edge rules. Sometimes you can also support this continuation by introducing visual elements such or objects like bridges, so which helps you to continue or to follow this edge path. And this brings me to the next and last aspect that I would like to discuss, namely technologies. And here, when I thought about this topic, it's really like, okay, it's a really, really large universe. There are so many different technologies that you can use to visualize and style your graph visualization. So that I said, okay, at this point, I need to reduce this to a small set. And this is basically a set that is also supported by the Y-Files library. But it's good to know so typical standards and then technologies that you can use because often they already solve some of these problems. So they give you the possibility to define schemes, or they give you the possibility or to define or select good color rules or schemes and so on. So here I would like to go through 4 of them, namely CSS, SVG, HTML, and WebGL. And I would like to start with CSS. So with the CSS, it's basically a style sheet format that you can use and that describes the presentation of a document and controls the layout and colors. And this is really nice in order to define a color scheme, or not only this color scheme, but also the thickness of edges and so on. So basically, this gives you the possibility to separate your implementation of your graph visualization. So basically, where you do all the layout code and so on, and then the definition of your visualization. As you have seen in this example for the for the example about the history of artists, there I also had this clear distinction between the layout code and then the CSS file defining the style. Here I would like to show you another demo that you can also use. So the source code is also available at GitHub, and here you can just change some colors. Let's say I change this to just guess something, and then I play the chain. Okay, maybe I should think about what changing. So I change the node type 1, and I change the color here to another color, and one moment. I haven't thought about changing this too much. No, now you can see the change. So basically the CSS file is directly connected to your graph visualization and gives you the possibility to really focus on the styling of the graph visualization without thinking about all other details like the layout of the graph visualization. And of course, you then can introduce the entire system of CSS for your graph visualization using all the different features that you know for this. The next technique is SVG that I would shortly mention. Here, the idea is that the graphics are represented by vector graphics, and this gives you also the possibility to introduce templates. So that you basically could say, okay, I would like to introduce a template for my node, and then I would like to specialize this template for different nodes, but I can use common tools to just create this template, and then I can specialize these templates in my application. So for example, in the Y-Files application. Here you can also find a demo that basically does this. So what we've done is we created one template, one SVG template for a node, and then this is specialized. And apart from this, these SVG graphics, of course, also have the nice property that you can zoom in as much as you want, and it's not like a pixel graphic that becomes imprecise then. But here again, you can use different tools and technologies that are also based on SVG, and then can use this result also in the Y-files library. Sometimes it's even more complex. So already SVG allows you some kind of interactions and of coloring dynamically these nodes and so on, specializing them. But sometimes it's you would like to actually use more complex ideas. So like you would like to have an HTML page inside of your node, for example, where you can actually input some data. And then this is also possible to use as a styling technique, basically, in Y-files. So what you do is you create an HTML style, and then you say, okay, the node has the HTML style, and this HTML style basically represents a div element. So basically one element of the HTML document. So here, this, for example, is basically an HTML element embedded into the node. And this gives you the possibility to really introduce different technology into your graph visualization. So here it's very easy. You can basically use this to change the status. You can open a calendar and so on. And this is not within the Y-files library, but this is attached to the Y-files library using standard techniques. And finally, I would also like to mention WebGL. Sometimes you get really large graph visualizations where techniques like SVG or HTML are overwhelmed. So basically it becomes too slow because you have too many elements. And of course, what you can do is you can use standard graphics libraries, so for web technology like WebGL, in order to render your graph visualization. Here, this is an example where we have a really, really large graph. And if you would render this entire graph within SVG, then it would become really slow. But I hope you can see this in Zoom. It zooms in very smoothly. And at at a certain point, it then switches to SVG rendering, which basically means that we now get all nice features of SVG. So typically SVG is more powerful than WebGL, especially about typography and creating styles and so on. So when we have a detailed view, so we only see a few nodes, then we can use SVG. This is fast enough for this. But if we zoom out at a certain point, when the detailed information is not important anymore, we can switch to WebGL and get the entire power of WebGL. Here in this demo, you can also change the threshold. So we can also go to WebGL only. And what you see here is that we here actually use now not vector graphics anymore, but pixel graphics. So if I switch back, now this becomes much more clearer because we use vector graphics. But you can combine these technologies, and it's good to know about how you can combine these technologies. So on our homepage, you can also find many examples how to do this. Yeah, and with this, I would like to wrap up the styling part. So what you've learned is that styling is not only about making a graph visualization beautiful by choosing nice colors and so on, but it's more about using styling as a tool to enrich your graph visualization with further information and highlight key information. So it's a really strong tool that you can use to enhance your graph visualization. And yeah, this concludes the styling part. In the next episode, I will take a look at the interaction part, talking about the most important aspects for interactions in graph visualizations. So just to give you an overview, there was in January the episode about graph analysis and layout, today about graph styling. Then in March, there will be the webinar about interaction techniques, and all of them are made in the same way, so that I show many examples, give you some ideas, but I don't show much code in this example. This is then be done in April, May, and June. So for each of these webinars, there will be also webinars for developers about the coding part. So how to actually do this, for example, using WiFile's HTML. And yeah, with this, I would like to go to the questions session. And if you have questions, then please feel free to ask them, and I'm happy to answer them. So I will have a look shortly at the chat and see whether there are questions, and then I will read them out loud and answer them. Okay, there's one question that says, okay, can you explain the importance of consistency in stylings across different visualizations? Yeah, so that's right. I have only considered one graph visualization, but it's typically also important to think about consistency across many visualizations. So typically not only create one visualization, but many different visualizations, maybe for the same database. And then here it's really important. Then it's really important to think about how this how the styling could be part of all of these visualizations, so that the user of this visualization only needs to learn the language behind the visualization once, so that the user only learns this for one visualization, and then he or she can go to another visualization and basically already knows about this visual language that you have defined. So this is a really important aspect. The next question is, often programs support switching between different color schemes, so dark light mode and so on. Is this also supported with the Wi-Fi libraries? So yeah, basically it's not directly part of the Wi-Fi library, but basically what you can do is you can, as I said, attach other technologies to the Wi-Fi library, like these CSS style sheets, which then allow you to define different color schemes. And then, of course, what you can do is when a button is pressed to switch this color scheme, then you can apply another style sheet to your graph elements, gaining this effect that you have different color schemes, so light or dark mode for your graph visualization. Actually, in the playground, we have one small example or two. There's also the possibility to switch on dark and light mode, and there you can also try this out. I think the last question, you have mentioned different web technologies that can be used with Wi-Files, yeah, like WebGL. Do you also support entire frameworks like Vue or React? Yes, we do this also. So Wi-Files for HTML can also be connected with the Vue framework or with the React framework. And if you are interested in this topic, you can find also webinars on this on our homepage, but also demos about this, how to use this actually. So there you can also have a direct look at the source code and see how to integrate these, how to integrate Wi-Files into these frameworks. I think this is the last question. Then I think, yeah. Okay, then thank you for your attention. And with this, I would like to finish and wrap up this webinar and wish you happy diagramming.